Okay. I'm working now in process engineering in the process engineering department at United. So welcome with me, Nabeel.
Good afternoon, everyone. Thank you all for being here in this late afternoon presentation. I'm giving this presentation on behalf of my colleagues who did also this study. My name is Nebeel Manqash. I'm working as a process engineer in process engineering department in United, one of the Sابك affiliates in Saudi Arabia. I would like to introduce my colleagues, Harish Patil, senior process engineer, Omar Marghanadi, process engineer and process engineering department in United Company. My colleagues and me are happy to handle any of your questions that you may have at the end of this presentation. Our presentation today will be about innovative computational tool that we use in United in order to predict heat exchanger performance and forecast plant shutdown for low plant. Our presentation today will be divided into 5 parts, starting with introduction, where we are going to give a brief introduction about linear alpha olefin, then the problem statement or the driving force behind this study, the study itself, which passed through 4 stages, the results and benefit out of this study, and finally, conclusion. First of all, we are going to talk about the brief introduction about the low technology. Linear alpha olefin are produced in United by having this alpha sampler technology, which is the technology developed by Sابك and Lindy Engineering. Low plant started in 2006, commercialized in 2009, and from that time up to now we are increasing our load in order to meet the capacity of the plant. Feed to this plant is ethylene, and we have 7 different products, starting from C4, C6, C8, C10, C12, C14 to 18, and C20 plus. So we have fresh ethylene feed to this bubble column reactor by process oligomerization process, and we are adding catalyst and solvent in order to react. We will have heavy low along with residual from catalyst and solvent withdrawn from the liquid phase, bottom of this reactor. Some amount of ethylene along with light low and heavy low will stream out of the reactor from top of it and will pass through a number of heat exchangers in series in order to recycle this ethylene back to the reactor. Our driver for shutdown is this heat exchanger E3601 because this is the last heat exchanger in this cycle, and it aims to condense the vapor phase to liquid phase. So due to nature of our process, polymer will be carried with the vapor ethylene and light low from top of this reactor. Again, top of reactor downstream heat exchanger will experience fouling, especially in E3601, as we said, because it is the last heat exchanger in our cycle. That will reduce the duty of this heat exchanger because fouling will form this layer, which will reduce the duty of this heat exchanger. And since we have only single line equipment in low plant, that means we need to go for cleaning shutdown in order to clean this heat exchanger to go back to the normal heat transfer coefficient. So that means we have only single line equipment. That means we don't have any bypass or any other heat exchanger in order to do the same job. So we give a bit of introduction about the lab technology. Now we are going to give the driving force behind this study. Why we did this study? As we said, we have 7 different products. These products distributed around the world. And since we are entering the market for the first time, that means we need to show our customer our commitment to deliver these products. So we would like to avoid, first of all, to have high inventory in our storage tanks facilities, and also we would like to deliver our products to our customer in time. Since we have only one lab plant in whole Sابek producing these kinds of products or variety of products, so that means we need to have internal coordination between supply chain, between manufacturing, between marketing, and also with our customers to indicate the time that we are going to go for shutdown. So these are the really driving force behind this tool, which will give us benefit to indicate the performance of heat exchanger E3601, and also will forecast shutdown for the plant. So moving now to technical part of the presentation, the study. Study, as we said, passed through 4 stages. The conventional way that we used earlier to indicate the performance of this heat exchanger is only by knowing the temperature of outlet of this heat exchanger. Unfortunately, that misled us for a number of times, which resulted to have inaccurate shutdown, and then we lose the production for a number of times due to the misleading data by using this temperature indication only. The innovative tool depends only on calculating the heat transfer coefficient and also taking into account the pressure drop,